Hello everyone, my name is Dr. Suraj Jaiswal and welcome to the first tutorial of the course entitled Technical Documentation and 3D Modeling. In today's tutorial, we are going to model your phone case. Yes, your smartphone covers. And in the process, we are going to use SolidWorks software. So as you can see in the sneak peek, this is what we are going to model today. And if you have no prior knowledge about SolidWorks, do not worry. I will take baby steps in this tutorial and using the instructions, you will be able to model even your phone case cover. So this is an overview of what you can expect from today's video. First, we are going to make a 3D CAD model of your phone case. So first we need to measure your phone and then generate a phone case from that. And in the process, we will use basic features in SolidWorks such as sketch, extrude, cut, fillet, smart dimension, and orientation. Then using this 3D CAD model, we will generate a technical drawing document. And of course, while making the technical drawing document, we will learn layout, edit sheet format, smart dimension, and PDF. So as you can see in the picture here, uh, first we will measure your phone, then we will build a CAD model, and then we will generate a technical drawing document from your CAD model. Okay, so let's get started. So this is your tutorial task that you need to measure your phone using any measurement tool you have. You can have a ruler, a measuring tape, whatever is available with you. So let's measure your phone. I have with me iPhone 13 here, so I will use a measurement of this one probably. And then once you have the measurement, we will generate a 3D CAD model based on those measurements. And then later we will convert that 3D CAD model into a technical drawing. So to start the process, first we need some measurement of your phone. Okay. If you have any ruler or anything, please go ahead and start measuring your phone. I don't have a ruler with me, so what I'm gonna do, I'm gonna search the technical documentation of iPhone at the first place. So if I simply go and search for iPhone 13 technical documentation, so I can already know the dimensions. Uh, 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 yeah, or maybe not this website, maybe this one probably. Yes. So I can see the width, I can see the height, I can see the depth here, right? In most cases, you will be able to get these technical documentations from any web browser for your phone, but it's not necessarily that you will get it all the time. So it's up to you, however you want to get the dimensions of your phone, correct? In this particular tutorial, I am going to use the dimensions which I have taken it from one of the web sources. So the width is 70.94 millimeter, the length is 143.57 millimeter, the thickness of the phone is 7.70 millimeter, and the fillet radius. What it means by that, so when we model the phone case cover, you will realize it's not pointed. The ends are not pointed. It's some filleting done here. So the radius of this fillet will be 13.39 meter. Okay, but please use the dimensions of your individual phone. That is important for you. Do not copy what I'm trying to do. Okay, now once you have the measurement of your phone, since we want to measure the phone case cover, so the phone case, we want to know what dimensions will be the case of this particular phone, for example. We need to add 2 millimeter we need to add 2 millimeter in the width of the dimension. So 1 millimeter for this end, 1 millimeter for this end. Similarly, for the length, 1 millimeter at this end, 1 millimeter at this end. Then for the thickness, add 1 millimeter into the dimensions. Okay. And also for the filleting radius, add 1 millimeter into the dimension. So that we know that the case thickness throughout is 1 millimeter. And that's why we are adding these 1 millimeter into thickness and fillet radius, and 1 millimeter into the width and the length on each side. And this is the measurement that I get. If you are using a ruler, please feel free to to uh, to round off these numbers to be 73 millimeter, 146 millimeter, 9 millimeter. For your case, the dimensions might be different, so please follow your dimensions. But let me take a screenshot of this dimension so that I will be using that in the process. Perfect. Now let's get started. So first and the foremost, go to the search window on your computer and type SolidWorks, or you can open SolidWorks from the shortcut on your desktop. So I have SolidWorks 2023 version. If you have similar version, well and good. But if you have any other version, the steps would remain the same. The principle will remain the same. It's only that the user interface might be slightly different. So do not worry about that. It will take a while for SolidWorks to open. Okay. So the moment it opens, it also gives you this particular window here. And if by mistake you have, let's say, closed this window, then you can go to this Welcome to SolidWorks button again and the same window will appear. Okay. What you need to do, you need to press Part here. So now my basic SolidWorks file is ready. As an user interface, you can I can quickly mention that over here there are all the tools available under different tabs: features, sketch, mesh modeling, markup, evaluate, multi-body dynamics dimension, and so on and so forth. And over here you have all the different uh, m- like features for your particular file, okay, for this particular model. And over here you have the dimension. So the dimension is such that x is horizontal, y is vertical, and z is coming out of the plane. So something like this: x is horizontal, y is vertical, and z is coming out of the plane. Okay, so it's in 3 dimension. Now let's go back to the slide and follow the slide as it is. Okay, so now you need to go to extruded boss or base. You need to click this option under features tab. Click this option. Then it will show you 3 different planes. So in the XY plane, you have the front plane. Then you have the top plane, which is in the in the XZ plane. And then you have the right plane in the YZ plane. Okay. What I need you to do is select the top plane. So if you take your mouse and left click, the top plane will be selected. So now we are in the top plane, you see, which is in the X and Z axis. Perfect. Now moving on. Okay. You need to go to sketch now. You are already in sketch because the moment you press the top plane, it will take you to that plane where you can make your sketch. So the idea is that we will make a sketch of our uh, phone case, and then accordingly we can provide some depth to it, so that so first we will sketch this part and then we will provide a depth to it. Okay. So under sketch, go to this option, center rectangle, and if you click this drop down, there are different options. Select center rectangle and then press on the center origin, left click, and then simply drag your mouse without clicking anything. So if you drag your mouse, you can select however you want the shape to be, correct? And click anywhere. Let's say I suppose that my rough dimensions are something like this. And the moment you select, your basic sketch is ready. Let's go back to the slide. I covered this part. Now you need to dimension your sketch because you don't know, you did not provide the exact dimensions of the sketch, right? You did not provided what is the length, what is the breadth. So now we will provide the length and the breadth. So go to Smart Dimension, select this particular line, or you can select even this line. It doesn't matter because these two are parallel and equal to each other. So select this line using left click, and if you just drag, you can place it anywhere. And if you click left click again, then it will show you this particular dimension. So you can actually put your dimension here, right? Now by default, like I have done the settings in my system such that everything is in meter. If in your case everything is in millimeter, doesn't matter. I will show you later that how you can change the basic unit from meter to millimeter or the other way around. So basically, there are different systems of measuring things, right? So I will show you that in a while. But remember the dimension over here. What is the length? Our length is 145.57 millimeter. So I'll type 145.57 millimeter. Either you type that, or if you want to replace this decimal by a comma, that also works. I'm using decimal here. And then you press enter. So now my length is fixed. And of course, uh, even though I entered things in millimeter, it is showing in meter here. Do not worry about it. If you click this again, you know it's in, like when you do the conversion, it's the right unit. So we entered 145.57 millimeter, so it is actually 0.14557 meter. Okay. Similarly, do it for this end as well. Click the breadth and then enter. So what was the unit? 72.94. So type 72.94 millimeter and enter. So the moment you define the length and the breadth of this particular sketch, the sketch is fully defined. You always need to make your sketch such that it's fully defined. So it is fully defined. Now if we go back to the presentation, I hope I'm not blocking anything in this one. Yeah. So we covered this part. Okay. So the moment you define your sketch, now we need to give this filleting radius, correct? This filleting radius, whatever you have measured. So what you need to do is under sketch, under the sketch fillet, select from the drop down. There are two options: sketch fillet, sketch chamfer. Chamfer is just if you need to provide a certain angle to it. But I want to make it smooth, right? So I will select sketch fillet. The moment you select sketch fillet, you need to provide what will be the dimension of this, what will be the radius of this fillet. For my case, the radius is 14.39 millimeter, right? So 14.39 millimeter and press enter. Remember, we are these dimensions, the moment we have added this 1 millimeter case thickness, all our dimensions over here became the dimensions of this phone case, smartphone cover, and not your phone, right? Okay. So the moment you enter your dimensions here, then you need to click one corner of your existing sketch. The moment you click, left click, and then it is asking you to do the right click. The moment you put the right click, you see the filleting radius is done. Repeat the process on all the corners. Left click and then right click. Left click, right click. Left click, right click. Okay. Once you have done that, then you can simply do it okay from here, or you can do it okay for here. Let's see what is shown in the slide. Both will mean the same thing. Okay. So if you do okay from here or okay from here, it will not matter. Let's do it from here. Okay. In the slide, it's shown here. It will take you to the same place. I do okay from here. So I'm still in the sketch. You see, I have not exited the sketch. I'm still in the sketch, but I say the sketch is ready. Now you can exit the sketch by pressing this option here or using this option here. I think in the presentation it is shown using this option here. So let's click this one. The moment you click this one, it will give you an additional uh, tab here, that boss extrude, meaning that now whatever sketch you defined on this plane, you can provide a thickness to it. You see over here a thickness to it. We have not done this slot, but just we are providing a solid thickness to it. Okay. If this option does not appear for you, if by mistake you have cancelled it or anything, from the features tab, you can, under features tab, there is always an option of extrude or boss, right? You can click that. But since it's already here for us, what we will do is we will provide the dimensions of this thickness. How much was the dimension of the thickness? Our dimension of the thickness was 8.70 millimeter. So we will provide here 8.70 millimeter and then press enter. The moment you press enter, and of course over here you see this direction. By default the direction is on the top, but if by any chance if your direction is in the opposite direction, click this direction again or click this one here. You can select the direction, you see. So I want the extrude to be in the upward direction and not in the downward direction. And the moment you press that, accept it from here or from here, it's the same thing. Accept it from here. So now my solid uh, object is ready. So like a basic feature, you see, if this was covered all together with some material, let's say, this is how it would have looked, right? Okay. Now let's go back to the presentation. I covered this slide, this one as well. Okay. Now what we will do is, in this basic feature, we are going to make this slot, make this cut over here, as you can see. Okay. So what we need to do, under feature, press extruded cut. The moment you press this, it will ask you to select a surface. So I say select this top surface. The moment you select, the surface is selected. Correct? Now I want to reorient things such that this surface is on the plane of the screen. What I need to do for that? So if you follow the tutorial, if you follow this presentation, in this view orientation, you need to click the drop down of this view orientation and you need to click this option normal to. So you want to see the normal of the surface that you have selected. So the moment you press this, you see now this is exactly like in this plane. plane of the screen. Correct. Okay. Now we need to provide another sketch which is at an offset. So we provided the outer sketch and then extruded, like we provided the depth to it like as a solid component, right? Now we want to make this sketch, the inner one, which is uh, at a thickness of 1 millimeter throughout. So what we will do is using simple under sketch using offset entity, we press this offset entities. Then after clicking offset entity, it is asking you to provide a dimension to it, correct? Or the offset entity is by default 10 millimeter, but we want the offset to be 1 millimeter. So what we do is 1 millimeter and we press enter, correct? Then click the surface. So now my offset is 1 millimeter, but if you realize it's if you scroll, you realize it's in the outer direction. You need to press this reverse so that it's inside now. Inside is 1 millimeter. And if you zoom out, you can zoom in and zoom out using center scroll. If you want to pan view, press Control and then press the center cursor and then you can pan view, correct? So these are the shortcuts which are not provided in the slide, but just for your information. Okay, so if I follow the slides correctly, perfect. Okay, we covered this part. Okay, so what you need to do is now you need to accept this from here or here and then exit the sketch. If I accept, last time I accepted it from here and things were fine. This time I want to accept it from here. I accept it from here. So I said my sketch is okay. Now I need to exit the sketch using this option or this option. The moment I press this one, again, this cut extrude depth came into the picture. So now it's asking me that, of course, you want to cut using this particular inner dimension, but what will be the depth of it? Correct? So now you need to provide the depth here. What will be the depth is you need to understand the depth this time will not be 8.7, but it will be 7.7 millimeter. Why? Is because you need to leave 1 millimeter of thickness for this inner surface. So from the top surface here, you just need to provide a depth cut of 7.7 millimeter. Okay, and not this one, this not 8.7 millimeter. This 1 millimeter is for the case thickness. Perfect. So now over here, you need to provide 7.70 millimeter and press enter. Okay. The moment you do it, you see this direction is also selected, right? Now, if you press the center cursor and try to rotate this, you will be able to rotate it. But I'm not rotating it at the moment. Okay. Let's not rotate it. Let's follow the way it is mentioned in the slide for you. So yeah, even it is asking you to provide this thickness to be like this. But if suppose by any chance this cut extrude is not coming for you, then again under features tab there is an option of cut extrude. You can select that and come to the same, arrive at the same location. Okay. Now you need to press it OK from here or from here. Let's do it from here. Press OK, and now if you rotate using the center cursor, you can see this is how your case is looking at the moment. So exactly we have modeled this feature. Of course, the slot is not there. We'll model it next. So this particular feature, right? Perfect. Now let's go back to the slide. Okay, perfect. So exactly, even our model is looking exactly like this. Now we need to make a hole for the camera. All right. So in order to make a hole for the camera, what we need to do, let's go back to our model. We need to click on cut, extruded cut again. Okay. And press this using left click and again select a surface. Now we want to make this inner surface of um, our phone case. If you rotate and select this surface, that should also work. It's up to you. I'm selecting the inner one. So I'm selecting the inner surface. Okay. Then using the inner surface, what you need to do is under sketch. So if you want to make this top view again, then go to this view orientation, top view. So now this view is here again, right? So now you are still within sketch, right? Because you selected the cut extrude, and now you need to provide a sketch. So every time you do extrude, cut extrude, or a normal extrude or boss extrude, you need to provide a sketch, and then you need to provide whether it's like you're adding a material or cutting a material from it as a summary. So now in the sketch, if you go to the straight slot, if you select from the drop down, there are different options to it. I am selecting straight slot. I select this straight slot, and now in order to make a straight slot, if you see from these options here, they need 3 points: point 1, point 2, and point 3. So if I zoom in using the center cursor, let's say I want it in this corner randomly, or let's say you don't know which corner it is, you randomly selected that it is first point is here, click using left click, then second point, of course if you want to give different angle you can, but our phones are not like that. So go to the 90-degree angle here, select second point here, then you need to provide how much is the radius, right? And select any random like point here, and then you select a random point here, like let's suppose this is how it is, and left click, of course. The moment you do that, your basic sketch is ready, but the dimensions you don't know. So how you can provide dimensions? Using smart dimension options. Perfect. So now let's go back to the slide actually. So after this, wait, yeah, I was somewhere here. Then we covered this slide, even this slide, and now this slide. So now, if you think about this slot, in order to fully define this sketch of the slot, what you need to know? We need to know that at what distance this particular slot is from, let's say, from this end, from the sides, from the top, and then also we need to define how much is the radius of it. Correct? Either you can define the radius of it, or you can define the length and the breadth of it, and the radius will automatically be decided. So if you define from this point to this point there is a certain length, and from this point to this point there is a certain breadth, then of course the radius is taken into account. So you need to think that carefully. Okay, let's actually follow the slide. I don't remember on top of my mind how much was the dimensions. So let's say this center of this particular feature is from the sides, it's at 11.82 millimeter. So what I go to my model, use select smart dimension, select this center line or the center point, both will remain the same thing. Select this and then select uh, the inner line, right? That's what it was. And then you can simply drag. So using the left click you are selecting these these 2 points, this point and this line, and then you can say what is the dimension. The dimension here of the moment is obviously random because we randomly placed the sketch there. But our exact dimension was 11.82 millimeter and press enter. The moment you press enter, you see the sketch shifted. So now we are actually defining where is the location of the sketch. Perfect. Similarly, repeat the same step. So from the inner surface here to the center of this point is 18.67. From the so smart dimension option is you're already within that option. So from this line to this center point. So using just left click. What was this? 18.67. Left click again. So 18.67 millimeter and press enter. So now you see at least the dimensions are shifted from 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 both the sides and the top. Perfect. Now of course the radius or the length and the breadth of this particular slot is something not how it is. And for your case, by the way, this is I'm giving you a reference of this dimension. Please measure your own phone case dimensions. For me, it's slightly different, so I'm using the one that I got from the technical documentation, and this is for one of the iPhones. I don't remember it for which one it is, but it's for one of the iPhones. For your case, use the one that you have. Okay, perfect. So now I know that the length of from these top end to top end of this slot is 24.23. So we will provide that in our model. So if by default if you unselect the smart dimension, you won't be able to select I mean the provide dimensions. You need to select smart dimension, select. If you zoom in using cursor, using a center cursor by scrolling it, you can either select the curve or the point on the curve, and then zoom out and then zoom in again, select this point on the curve, and then you can provide zoom out using press control and center cursor to just pan it, and then you can provide what is this length. What was this length for our case? It was around 18.67 millimeter. Enter. You see, now our length is fixed. So exactly 18.67. Now the width is not known, and that's why it selected the random width. But for our case, the width is 11.26 millimeter, right? So let's go back to the slide. So select this particular line of the width and this particular line of the sketch. And how much is the one? 11.26. 11.26 millimeter and press enter. Oh no, I defined something incorrect. Wait a minute. Okay, so you see there is a problem. The problem happened. So the width is fine, 11.26. You can see here. If you click this, 11.26 millimeter. So it's 0.01126 meter, which is fine. But there's a problem with the length. For the length, by default, it took the length. I don't know. This length is from this point to this point, and that's what is the problem. We wanted the length from this end to this end, right? So if you make these errors, it's easy for you to like delete the dimensions. What you need to do, select the dimensions and press delete. No, not like this, sorry. Select a dimension and press delete. Press delete. Okay, and it's deleted. So go to smart dimension again by selecting it. Select the top curve, select the bottom curve. No, it's still selecting the center points of it, and that is the mistake. So press escape, it will escape from it already. We need to select this center point and then provide dimensions with respect to this center point. We want this distance to be 24.23, and we want this distance to be 24.23 millimeter. Enter. Finally, and click anywhere on the screen, left click. This is what we wanted, right? This was 24.23, and our slot is exactly looking the way it is looking right now. So the moment you do that, this sketch is fully defined. Okay? So make sure you have done this carefully. Now, once it's fully defined, what you need to do is you need to exit the sketch. But before that, let's follow the slides. So I covered this slide. I also covered this slide. And remember, if you over dimension your system, it will give you a warning mark in yellow color. We have not over dimensioned our system. Everything is accurate, so things are fine, correct? I also covered this slide. So we have completely defined our sketch for the slot, right? And then, like I told you, we need to accept it using this particular option here. So exiting the sketch basically. So let's do it. So you need to exit the sketch either from here or from here. Let's do it from here. Exit the sketch. The moment you exit the sketch, it will ask you, of course you can't see here, but the moment you press center cursor and roll, it is asking you how do you want to cut extrude this, right? You see it's by default selecting a plane. You say this time that you want the cut direction to be, of course you selected the dimension direction from here, either you can select it from here, but since we have drawn the sketch on the inner surface and we want to cut it throughout till the outer surface, so we select the direction to be inside, so within the plane of this surface, right? And then we say we don't need a blind cut, we need a through all cut. Through all means it will cut everything that will come in its way. And you select that option. You see already this is showing you something like what's gonna happen. And then you need to press this accept from here or here. Let's do it from here this time. The moment I accept, you see it has made that slot for you. Now it's started looking more like how our case cover is, right? Like a tentatively, not this one exactly, but how usually a case cover is. So using the center cursor, you can rotate and see how it is, or you can press Control and center cursor to pan view. Okay, so now how this is how our system looks like. But if for some case, if that cut extrude option did not came for you, so under features, you can always go to extruded cut and then you can always get that option. Perfect. So now this slide I covered already. So now our model is ready. Okay. And one thing as a good modeling practice, we did not save our model. You should save our model, because if for some reason your system crashes, your every all your efforts will go into vain, right? So before proceeding anything, we will save our model, and then we will generate the technical drawing document for this particular model. Perfect. So this is our 3D CAD model of our phone case. Of course, you will complain me that hey, there are additional features here like for the volume button, for the other slots, for speaker, for microphone and things like that. If you want to make your model that sophisticated, feel free to do that. But it's not required for this task that we expect you to do. So if you have done something like this, it's fine, correct? But if you want to model these extra features, what usually are there in the phone case cover, follow the same principle, follow the same steps, and obviously you can arrive, you will be able to do it yourself. As a summary, you need to select a surface, make a sketch, then extrude. Select a surface, make a sketch, then make a cut through. Exactly the same steps what I taught you. But before that, we will go to files, save as our model because it will be lost otherwise, right? And you can save it wherever you like. So I want to save it in this folder, and I'm renaming it as phone case model YouTube. Okay, and the extension will be .sld part, so it means SolidWorks part file, and I save my model. Remember in the beginning I told you that all the units that I provided are provided in the slides are in millimeter, but in our particular SolidWorks file it was in meter. How you can change that? So if you go to I think tools, if you go scroll down, there is this options here. Select this options. It will open a new window. So they have two tabs, system options and document properties. I go to document properties, then I go to units, and under units you see there are different conventions, different unit system. So the MKS system, meaning all lengths are in meter, all weights are in kilogram, all time is in second. CGS, centimeter, gram, second. MMGS, millimeter gram second. Why for me it's in MKS? Because usually we follow SI unit in everything we do. So for that reason I have selected MKS. But for your tutorial we are following millimeter as the length, right? So we select this option MMGM. So all the lengths will be in millimeter, right? And press OK. So the moment you press OK, and if you want to see if it actually the changes actually happened, obviously it's just the change in the unit. The model will remain the same. What you can do is if you go to any of these boss extrude or cut extrude, let's say I go to boss extrude, if you select from this drop down and select sketch, if you double click the sketch, now you see everything is in millimeter. Because earlier we defined it as 145.57 millimeter, but then it was showing us to be 0.14557 meter. Now everything is in millimeter, right? So things are fine for us. Perfect. Please save this again because we made a change. So I saved it again. Okay. Now our 3D model, 3D CAD model is ready completely, and we want to generate a technical documentation from this. What I want you to do is go to files, then select make drawing from part. Select this option. The moment you select this option, a new window will appear. For me, by default, this sheet format option is coming. But if you follow the slide and the moment you press this option, a new file appears where it will ask you what do you want to create. And over here under template you will have the option of drawing, so you need to select click drawing and then press OK. If this option is coming for you, then you need to do that. If it's not coming for you, it is fine. For me it is not coming because I think that is pre-selected already, so directly this option is coming. So if I go back to slide, so for you after this option it will lead you to the same place where my current model is, right? So for me it is already showing me this option. So what I want you to do is from the standard sheet size, scroll down and select. So these are the different standard sheet size which is followed in engineering throughout the world. In this one, an ISO standard is one such standard which is it's very popular and it's used by many organizations, many companies, and then at many institutes as well. I want you to select A4 size ISO sheet size. Obviously, these A4, A3, A2, A1, A0 are such that for suppose if this is A4, right? A3 will be double of this one, so it will be something like this. Then A2 will be double of A3, so it will be even bigger. A1 will be double of that, and so on and so forth. So select A4 and press OK. If you select A4, it will already show you the width and the height. Is in the preview window also you can see. And this is being selected from the already existing file in the SolidWorks uh, um package that you have installed in your computer, or if you are following any of the university's computer, it's fine. And press OK. The moment you press OK, it will lead you to this new uh, layout, where of course over on the top things, there are tools. On the left there it is about your particular sheet, and on the right you will have different palette views. So let's follow the slides. Okay, now what I want you to do is, if you go back to the model, I want you to take your mouse to this view over here. Okay, then select this A top. So if you click, you need to keep pressing it. So okay, so it's giving me the reminder this document has not been saved for at least 20 minutes. I will save it in a while. Let's cross this. Okay, so you need to press this top, keep pressing it, and drag it to this location here. You can keep at any location, that is fine, but I drag it to this location here, and then I leave my left cursor. The moment I leave, it shows something like this. Now do not do anything. Then just drag your mouse and it will give you different views, if you see. Correct? So just drag your mouse without clicking anything, and it will give you basically the top view of this one. So drag to this location and left click. Similarly, drag to this location and left click. Similarly, drag to this location and left click. So now all my different views are ready. Now what you need to do is you need to just press OK from here or from here. I press OK from here. So now it's ready. Okay. Now you need to provide dimensions to it. And remember, in the sheet you have you selected the sheet format, then you selected 4 different views. This view, this, so it shows in the orange color. If you select also, it will show you this one, right? This view, this view, this side view, and then the isometric view. So this is basically, I think, the front, the top. Oh, okay. Okay, how this top, front, right are defined? You remember we defined things on the top plane, right? And we made a sketch and everything on this plane. So for this reason, this view is considered top view. So this is the top view. Then this is basically the side view, and probably the right side view. This is basically the front view, the way I'm seeing the screen, if my model is like this. So this is how this top, front, and right or left view is selected, right? And of course this is the isometric view. Perfect. Now under annotation, don't go under drawing. Under annotation here, you need to go to smart dimension so that you define all the dimensions of it. And remember, these technical drawings are should be made in such a way that if an engineer sees this drawing, he's able to make the same model that you just made. So you know, you do not need to under define it, you do not need to over define it. You need to define it sufficient enough that it makes sense for anyone who just see this sheet and is able to replicate your model. Perfect. So let's go back to the slide. I covered this part already. Now let's cover this part. go back to the model. So let's zoom in and go to this view by just zooming in, not clicking anywhere. Okay. Under annotation, select smart dimensions. Okay, so under smart dimensions, you have different options. If you want to just provide horizontal dimension, vertical, uh, different options. All I need to you to do is just select smart dimensions. Okay, so it will interpret on its own. Smart dimension I select, and now I need to define the the width of it and the length of it at the first place. Remember we started with that. So I press Control and center cursor to arrange it in such a way that I have enough space. And then I select the outer line and then again the outer line. And of course, you see it's already interpreting the data on its own. Correct? So using left click, you selected this line, that line, and then if you simply move your mouse, it will show you something like this. You need to press left click again. And of course, you can put it anywhere, but is it a good idea to place your dimension outside the layout of your sheet? No. So try to place it in such a way that it looks good. So let me put it somewhere here and I press left click again. So now my this dimension is ready. If you press it anywhere else, you can see this dimension. And of course, you see 0.07 and you say, hey, I don't understand. It's not making sense for me. Is because this unit is in meter, right? If you zoom out and press Control and center cursor and zoom in, wait, sorry, press Control or center cursor, zoom in. This dimension, we already know, we obviously know it's in meter. But if you press Control and center cursor and go to the title of this, it's saying dimensions are in millimeter. So it's the default template and it's saying everything is in millimeter. Either you can change this to be meter here, uh, which is not a nice option. So yeah, under sheet, you don't need to press Control and center cursor. Even if you just press center cursor, you will still have the pan view, right? So now I need to first make this meter dimension into millimeter. What I need to do is a similar step what I did for the 3D CAD model. So the 3D CAD model is a separate file and this sheet is a separate file, right? So don't get confused. So before I proceed anything, I go to again tools, then from this particular option here, scroll down, select options, then from the two tabs, select the document properties tab. Then under units, select mmgs, millimeter gram second. Press this option and press OK. So now you see this unit became into millimeter. And of course, the title page says everything is in millimeter, which is good. So remember, do not confuse yourself with things and do not mix up units. Perfect. Now, once we provided that width, we also need to, the smart dimension option is still selected for us. If by some reason it becomes unselected, then you won't be able to dimension it. You need to click this smart dimension again, zoom in using cursor, select the outer line, then select the outer line from the bottom, and then just move your mouse and click anywhere so that you have enough space to see this dimension and click. Remember, this was the only dimension we provided, 145.57. You see, 145.57. Of course, this is decimal here, and over here it is showing comma, which is again a matter of convention. You can similarly go to the same location and change this unit to be, instead of comma, to be period, and other way around. It doesn't matter. So now my length and breadth is fully defined. What I need to define next is the width of it, correct? So how I can define the width? Under smart option, if you just select this top surface from this particular view, this top line or surface, select and then move your mouse, and then either you can place it in the center like this, but usually we place it such that it looks beautiful, right? So if you place it like this, it's also fine, but I usually follow this so that everything is clear and things are not overlapping. So I left click again. So my width is 8.70 millimeter. Perfect. So now I have fully defined the way I started. I fully defined the outer dimension of it. Now what I need to provide next is the either the thickness of this particular feature and of this cut extruded that we had, and then of course the dimensions of the slot. Okay, but before that, let's follow what's there in the slides so that I'm not going off track. Of course, we covered this part as well, even the previous slide. Yes, filleting radius, correct. This is something we missed. If you go back to the model, we also provided the filleting radius in the beginning, right? So under smart dimension, if you zoom in using your center cursor, if you just select the outer radius, left click, and then move your mouse anywhere, and then if you make this uh, mouse just move and left click again anywhere, you see 14.39 was the radius of this one, right? And left click anywhere on the screen. So now my basic dimensions of this particular thing is covered. So basically the length, the breadth, the depth, the radius. You remember we started with exactly these things: the length, the width or the breadth, the filleting radius, right? Then also the thickness. The thickness was 8.70 meter. It is 8.70 meter. So all these four things are covered here for us. This is something which is not covered, and also the dimensions of the inner slot for the camera. We will do that. Let's go back to the slide. Yeah, next is exactly that part. So for the dimensions of the inner slot. Perfect. So before you do that, you realize there are no points in here. So how will you define that? So first we need to define the points. Go to sketch over here, and if you see there's an option point, click point here, and then you need to just define these points onto this 2D drawing to add as a reference point. So first select this point on this particular curve. It will by default prompt you the center of this curve. Left click, so that point is selected. Then again come to this curve, repeat the same process. Left click, this point is selected. Then select a point at the center. How you can do that? Of course, it is showing a lot of different points over here, but try to be around center and you will realize that there is a center point somewhere here. And let me zoom in a little more. The moment you zoom in, it will give you a lot of point options. The moment you zoom out, it will give you just one option, which is at the center. This is the center point. You need to be very careful with that, okay? Perfect. Okay, then once you have done that, all you need to do is press OK. Perfect. Now let's go back to the slide. Now we need to define this slot. Okay, in order to define this slot, what we need to do is we need to provide the distance of this slot from the sides, from the top, and then also the dimensions of the slot itself, so the length and the extreme distance, which will be fine. So what I need you to do is go back to the model, go to smart dimensions, or from annotation, then smart dimensions. Then select the first point here by left clicking and select a point or a line, whatever you like. A point or a line will be the same. I'm selecting this. It's shown a point in the presentation. Even you can select the line. Select this point or a line, and then of course the moment you move your mouse, it will show you different dimensions. Be very careful that you go in the upward direction, and then left click again. So this is 12.82. It was exactly this, right? And press OK. Do not make any changes here. Select. Okay. Now left click anywhere on the screen. This dimension is ready. Now if you want to move this dimension the way I did it, for example, this one, all you can do is you can left click and select and then simply drag to just change how it's looking. Okay, I change it to be like this and left click anywhere again. Okay, similar way, you need to define the same distance from the top of the feature. I think it's the top of the top surface only if we go back to the slides. Yeah, it's from the top point here or the line here. It's the same thing. So last time I did it with the point, this time I'll do it with the line. I'll show you that it will mean the same thing. So under smart dimension, click this point. Then instead of selecting this point, select this line. It will mean the same thing, guys. Select this line and you realize that you have your dimension here and left click. So 19.62. Aha. But if I realize this is 19.59, so there is a difference. Let's see. If I press OK, this is 19.62 from the top. And let's delete this. Select and delete. If I do the same thing, go to Smart Dimension, select this point and select this point, it is the same. You see 19.62 and press left click. So it's the same dimension. Press save the existing one. But if you realize we selected a random point here and probably it is not at the center. You remember there were some problem while selecting it. So it was not selecting, we were not able to select the center point, it seems. So there's a difference of decimals. But in this case, it was coming to be 19.59, right? So how we can do it? We can, let's see if I'm able to change. So if you double click this dimension, and if you say this is 19 point, let's say 59 and press OK, I think it made that change. But whenever you are selecting this point, remember you are selecting it very carefully. So this is basically showing the two distance here. Okay. Usually I should not make this change like this. This is kind of uh, the wrong way of doing it. So I'll delete it. I'll try to find a point which is exactly 19.59. So I select delete this. Then of course let me delete no, not let me delete this dimension as well, and let me select and delete this point as well. Go to sketch again, go to point again, and now I will try to select a point here. Okay, exit using escape. Let's delete even this point by selecting and deleting. And go to sketch, go to this point. After you have selected this point, select, try to go to like you have selected this point, right? Try to go. Actually, I'm not able to provide. So I thought if I'll select this point first and this point and then this point, it would do. But I think it's not. So we did the right steps at the first place. And it's good to see that your teacher is also making a mistake. So that's a good sign. If even if you have made a mistake. So select this point. It's fine. Then select a center point. The center point will be slightly off, I believe, because you see this thing is like interpreting things to be slightly different. So select any random point here. And of course, this random point, it is showing how much you want it from the this vertex or this vertex. So you can define this line here already. Okay. Okay, perfect. Or if you want to define a relation, uh, you can fix this using this option here, but let's not fix it. Delete. So we have not fixed it. This point is movable because we will provide the dimensions and then we can fix it. So close. And please repeat the same thing for dimensioning. So go to dimensioning, select this point, select this point or this line, and it was 12.82. Perfect. Then again select, yeah, this was perfect, 12.82. Then again select this point and select this line, and this distance was something like, now it's 19.17. You see, it's so different. The moment you select, provide the right dimension, and I think this point will be adjusted accordingly. So the moment you provide 19.59 millimeter and you press enter, I'm hoping this point will move a little bit. I enter. Yes, this point moved. Please repeat this part of the video and see this point moved. So this dimension what we have provided, now it's the accurate one. It's not a manipulation. Earlier we were not able to see this slight movement because from 19.62 to 19.53 you cannot see like the movement correctly, right? But now the moment the movement was like huge, we could see it. So now this dimension is accurate. Perfect. Now let's go to define the dimensions of the slot itself. So go back to the slide. Under smart dimension, let's select this end and this line of of this particular feature. And remember, your dimension should never be inside the object. Always your numbers should be, you cannot place it like this. That's the wrong approach. You need to place it outside this object. So just place it outside this object. So that was 11.62, which is what it was. Then also again select this top point and this bottom point and this dimension. It's 24.23 and select. So it's saying make this dimension driven. Yes, press OK. And if you press anywhere else in the slide, you will realize few dimensions are in black and few dimensions are in gray. Why is it so? It's very important for you to understand these gray dimensions are actually coming in from your solid 3D CAD model that you made. So these dimensions are the ones which were defined in your CAD model, or it were interpreted from this one. Correct. But this, the dark black line, the black dimensions are coming is because you defined it within this sketch. Because you remember we defined these 3 points and this point was not sure. So then we are defining that this point is at a distance of this particular location from the side and this particular location from the top. And that's why, and we can play around with this point by changing this dimension. That's why it's coming in black. Very important point. Obviously, these things are not mentioned in the slides, but it's for your understanding. Now let's go back to the slides. Obviously, we covered this part as well. And then of course, the last point is the width of our phone case. So this width, the moment we define this width, everything is fully defined. So using the center cursor, just press drag. Under smart dimensions, scroll in. So select this line, and then zoom out and place it anywhere. So this is 1 millimeter. Left click and press OK. Close dialog, I mean. And if you zoom out, you see your 3D model is fully defined because obviously you defined the length, the width, the thickness, the fillet radius, so the outer part was defined. Then you defined the inner thickness to be 1 millimeter fine. Then you defined completely the dimensions of your inner slot. And that's what we used at the first place, right? So if anyone wants to repeat exactly the uh, same modeling, what you have modeled, if he has access to this particular document, he or she will be able to make the model at the first place. And this is the importance uh, of these technical drawings in industry or anywhere you go. You will always be given these kind of technical documents, and then you are expected to make the models by yourself. So it's very important that you know how these technical documents are made at the first place. So there's obviously a standard, and obviously we are following those standards here, and then we can make it. Now let's go back to the slide. Obviously we covered this part, and this is something we covered in the beginning itself. And then we want to edit the sheet format or the sheet properties. So go back to the model. So if now, since you are out, you have defined everything and you are outside the sketch, outside the smart dimensions, if you right click on any empty space, if you right click, then go to edit sheet format. The moment you press this option, it will take you, so obviously you can't see here because it's zoomed in. If you zoom out using center, like scrolling the center cursor, and then press center cursor to have the pan view, you see this part is highlighted here, correct? And you can change the details here. Let's see how it is mentioned in the slides for you. Perfect. So now what I want you to do is, first let's go back to the model. Now under I think it's under annotation, then note. Select this option. I want you to provide a note for the material, that what material this is made up of. This is made up of silicon, right? If for your case, if it's made up of something else, please feel free to provide the details of whatever it is made of. So it can be the plastic, silicon, metallic case cover, wooden case cover. It's up to what case cover you have, right? Now, if you go to this material, first you need to create the box here. So this box is interpreted already. And then you need to, if you just put your mouse here, it will show like this. And you need to press left click, and then you need to type here. I type silicone. And you can let the text style and the text font as it is. And press silicone and press not enter, and that's it, right? And you can simply close this and press anywhere on the slide on this sheet. If this option is coming, press escape, it will be gone because you were still in that node option, and that's why it was coming. So my material is silicon, I know that. Perfect. Now next is, if you double click this phone case model, of course you can change. So this took the name of exactly what the file name I provided. I say that this is my phone case, right? Phone case for iPhone. Let's say iPhone. Well, let's say iPhone 13. For your case, you need to say which is this phone case. Phone case for your whatever model phone you have. Now you see it's not fitting in here. Obviously, you need to change the font style here. So I make the font style to be 12. Ah, no, 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 no. So select in the text, press Control A. So the entire text is selected, and now select 12, or maybe I'll increase it to 14. So you see, and then of course, if you click, you can click anywhere, this, click anywhere else, or press escape your phone case. should double click this again, uh, and press cancel. Yeah, but yeah, press anywhere else. This is how it will look. Phone case for iPhone 13. Perfect. Let's follow the slides actually. Okay, there is also some extra text written here if I'm blocking anything. That if there is arrow, you could unselect it from the bar on the left side in some field. There is empty box reserved. You just need to move your mouse in that area and sometimes the box will automatically be detected. So it is saying sometimes you need to define the box here, but in some other field, the box might already be there. So the moment you put your mouse there, it will be auto detected, right? That's what it's trying to say here. I'll show you in a while. Of course, we also double click this phone, this title area and provided our own. Now we need to provide the author name and it's very important. So let's go back to the model. I select under annotation note again and then drawn. If you zoom in using scrolling, you select you see this. You can select anywhere here under this drawn box. Left click and it will ask you to provide the author name. Let's say I provide my name Dr. Suraj Jaiswal and I press close. You see this text is not double. Press escape. Okay, I need to delete one of it. So select one of it, press delete. So this text is not fitting in here clearly. If you left click and just drag, it will show. Double click this, then press Control A, change the size of the text. I'll make it even smaller, let's say 6 mm, and press enter. No enter, sorry guys. Do that, press escape. So now my text is at least within this size, and then I will select the text again and I will simply drag and arrange it the way I want it to be here. So now the one who has drawn this technical drawing, it's also ready. Perfect. Let's go back to the slides. Okay, so the moment you do this and you realize that you have not saved your files, correct? What you need to do is you need to scroll out, then at least you see the things in here. Now the moment you scroll out, you need to press this exit this edit sheet format because you see the sheet format option is selected here. Exit this. If you do not exit it and then you try to save your document, then probably you will be saving an empty document, meaning that only the title box and things like that will be there and all of these will not be there. Okay, press escape. I just to show you. So before you save it, just see how it is looking here. Or if you use print option, like if you go to under file, there is this print. If you want to see, you can even see the preview there, right? But let's go back to the slide. Okay, now in some cases was a simple example, so everything was fine. But suppose if some of the views in if you're modeling something else, if some of the views is too small, what you can do is you can select a view. For example, if you take your mouse here, select this view, and if you scroll down here, it's a scale it shows here. You can use custom scale and provide your own ratio over here. Like, how do you want this view to be scaled up? Do you want to be bigger in size, smaller in size? And you can change this scaling and accordingly provide the scale. Where is it? Scale option over here, or it will be selected automatically for you. All I'm saying, use the sheet scale only. So whatever the size of my phone is, this sheet scale is, if you zoom in, this sheet scale is 1 is to 2, meaning that whatever the size of my phone is, it's making it 1 is to 2. It's making the dimension to be, I mean the view, the moment you view it, it's making it half. So if you print it in a PDF paper, and then if you try to compare this dimensions with this one, you will see, hey, it's not matching. Why? Because the scale has been reduced. So it will be probably half the size of this particular actual uh, uh, object here, right? Perfect. So we are not making any changes here. So let's close this dialog box here. Perfect. So at the moment, your model or your sheet should look like this, where all the dimensions are readable for you, right? Everything is readable. Make sure everything is readable here. Do not make it in such a way that the dimensions are overlapping and you cannot read the numbers. Of course, some lines are overlapping over here. That is fine. But the numbers should not be within this object, and the numbers should not overlap each other. So you see, this is a clear representation of how it is. I'll show you a bad representation if you see this particular slide. You see, even this one is a clear dimension. Everything is readable and everything is fine. But are you able to interpret any information from here? Probably not. So make sure that you place your dimensions in the right way and not in the wrong way. Okay, perfect. Now let's go back to the model. Now we want to save it. So go to File, go to Save As. I want to save this file in the same location where I saved my SolidWorks file for the YouTube. Now this one is saving by default as a SolidWorks drawing. Of course, I will suggest you to save it as a SolidWorks drawing, because then at later stage if you want to make some changes in this particular sheet, you can. So my suggestion to you would be, first save it as a SolidWorks drawing file, save. So now my SolidWorks drawing file is here, which is ready, which is good. Now if you want to generate a PDF from this one, simply go to this file again, save as again, and now from save as type, select it to be a Adobe, Adobe Portable Document Format PDF. Select this option. And now, obviously you can rename it as you want. I have already named it, if you remember, phone case model for YouTube. It's fine. Save. So now I have saved this. I already saved this original 3D CAD model, which is the SolidWorks part file. I also saved this particular model, which is SolidWorks drawing, and then I generated a PDF from that. If you want to ask me how does the PDF look, I can quickly show you. So remember, this is the document that we just made, the PDF, right? So if you double click this is how your PDF should look like. If you scroll down, you see it's made by Dr. Suraj Jaiswal, material is silicon, title is phone case for iPhone 13, it's A4, and of course dimensions are in millimeter, which is important. And all the other important information also you can provide, but we will uh, teach that to you in the upcoming tutorial. Do not worry about it. But of course there are four views in this particular files, and obviously it's under this sheet, so you can see this over here. So this is how it should look. Okay, with that, let's go back to the slides and let's see if I've covered everything. Of course, I have covered this part as well, and you can see how the file looks like. So as a summary, first we measured our, so you measured your own phone and we took the measurements from the technical documentation. Then we made a 3D CAD model, and while making the 3D CAD model, we saw that how we can make sketch, then extrude the object, then again make sketch to extrude cuts, then use smart dimensions to actually dimension it properly, and then using this view orientation, we provided there's a spelling mistake. It's VIEEW. Using V orientation, we saw how we can actually model, view different orientations. Then also we learned about filleting. So in order to provide this smooth corners, that's what we learned from SolidWorks, and that's what we promised in the beginning. Very good. Then we generated a technical drawing of this particular 3D CAD model, and in making the technical drawing we learned about what kind of layout we can use, how we can put different views into this particular sheet. Then obviously we also edited the sheet format, and obviously we when we edited the sheet format we provide different details of it. Also, we use smart dimension over here to provide the dimensions of different views, and in such a way that it's completely defined. So if anyone wants to see this CAD model and wants to follow it, he or she should be able to completely replicate your model using these dimensions. Okay, and then we also saw how we can save it at the first place as a PDF document or other related documents. In the future, if you want to make any changes in this sheet, of course you cannot do it in the PDF, but you have this phone case model youtube dot sldrw SolidWorks drawing. You can go to this file. It will take you to this particular file, and you can make changes there if you want. And of course, if you want to make changes in the SolidWorks file, then it is this one, phone case model youtube.solidworks part file. The extension is .sldprt. Perfect. So with that, I come to the end of this tutorial. So if you still have any questions, please feel free to post it in the comment section of this video. Or if you have access to the email address of any of the teaching assistants in the course, you can just email it to any one of us, and we will try to get back to you as soon as possible. But I hope I took these baby steps and you will be able to now uh, generate your own CAD models and technical drawing of your phone case cover. So if you have done that, superb. With that, thank you so much. Thank you for following this tutorial, and please like, share and subscribe to this channel for more interesting videos in the future, and I wish you a good day ahead. See you.